backend. And that also connects to database now, my dear. Super. Yeah, and this is the one thing you have to understand: project setup, UI, backend, and database. That's the one thing, right? Okay, next one. Project also deals with the profiles now, my dear. Already we discussed a long time, right? Okay, developers packs the code into Git repository, and in that, come on, guys, that code will be listen. That code will be taken for developer machine having development profile. There are different softwares we use, right? And for testing, we use different software. Check it out. Here, Windows MySQL. Here also what? Windows MySQL. Next, UAT profile. Uh, Linux OS MySQL. OS is changed. Did you notice this? Pre-production. Before release, whatever is there, pre-production. Linux Oracle I am using. Okay, prod environment. Linux Oracle Wildfly. Best servers I am using, right? Okay, now listen, guys. Total 4 or 5 setups we generally create. Code is same, but environment is changing. Code is same, environment is changing. Okay, instead of this kind of thing, instead of that, if I create 5 Docker containers having 5 different environment and same code, so they can be used in any mission or not there, guys. They can be used in any mission or not there, guys. So that's a code plus environment packing. In profiles creation also, Docker containers are very, very useful. Are you getting my point there, guys? For every profile, we need to keep one Linux VM instance of AWS ready to develop and deploy. If at all you are using cloud, we need to create these virtual machines in what? AWS are not there. Dev profile VM is for both development and what? Unit testing. Test UAT pre-profile VMs are purely for what? Testing at various level. Prod profile VM is for purely keeping project in live code for end users are not there. Super. The test that happens at client organization after releasing the project is called what? UAT, user acceptance test. What test, guys? User acceptance test. Where is this, guys? Okay. If you don't have, so I'm talking about what you know. First, forget about Docker kind of thing. There are 2 things. Every project contains UI, backend, and database. That's one setup. Another setup is what, guys? What's another setup what we are having, guys? Developers will put the code into Git repository or not there. Okay, from Git repository, come on. These many profiles will be created where code remains same or with small changes. Setup will change or not there. Okay. So to do all these things, let us assume I don't have Docker. DevOps team is responsible to keep these profiles or environment machines ready to develop or test project in different environment. So DevOps team feels bit heavy or not there. They need to keep 5 machines ready. In all mission code is same, but setups are changing or not there. Okay, no, they are not using a regular mission. They need to create such setup in AWS environment or not there. If Docker is not there, come on. The DevOps team needs to keep what? All the profiles and environment very much ready manually, which is complex process or not there. Very much ready manually. Sometimes software company mission setup, development and test may not match with what? Client organization mission setup, cloud or outside cloud. We generally observe following what? Mismatches. Suppose, see, software companies use a certain setup. We ask the client keep the same setup ready. Suppose they have not done properly, guys. Mismatches will come. When mismatches comes, okay, code execution gives problem or not there. Why all this stuff? Let the software company people only create Docker container, having code and environment, release to client organization. So now client organization need not to keep the setup ready. They just need to take the Docker container and execute it. So more portability is coming for the code or not there. Super. The software company uses Windows machine or Mac machine for development, but the client organization use what? Ubuntu or Linux machine. So code will not run now, guys. Software company might have developed Java code with Java 11 setup. The client organization may be using 8 setup. They say both Java, no, the difference is there. Software company might have used Oracle 11G and client organization might have used 11, 12, 19C. All these indicates compatibility issue to run the project code in different profiles or what machine. If software company release the software product to what? Multiple client organization, then keeping the setup ready for all those client organization become big headache for what? Software company are not there. Not for one client organization, they are releasing to 1,000 clients. By going to 1,000 client organization, keeping setup for them is very difficult or not there. Sir, why they release for 1,000 companies? Think logically, Babu. So it is not a project. Let us assume I am releasing product. Tally kind of accounting software. I'm releasing to 1 lakh customers in the world. So will I go to 100 people and to keep the setup ready? Is it possible, guys? We give guidelines. When you give guidelines also, they do mistakes, right? Suppose some schooling related ERP software is there. School people are non-technical people. They don't want to keep a technical team also because it's a burden for them, right? So will you go to every school to receive the project and to install the project? It's very difficult or not then? Okay, one time we have sent and done. What about other time? What about other time? Whenever problem comes, you have to go or not there. Why all these headaches? It's better to say, I'm releasing Docker container. Ask them to install Docker in their machine and project runs. But everywhere Docker should be there. But to run the Docker container, Docker software is required or not there. So installing one Docker software is easier. Installing a number of software and running the code is easier. Yeah, that's good. That is called containerization. Life with Docker, guys. Docker automates the environment or profile setup process by using the concept called what? Containerization, which performs code plus what? Environment packing. Development container, test container, UAT container. Code is same, but softwares are changing or not there. All these containers are created on the top of Docker engine, and that will run on what? Regular OS. That will run on regular OS. See, 10 client, one client Linux, but their Docker software is there. In that one, Docker container is there. Inside that Docker container, the compatible OS, compatible DB is there. It's nowhere related to what? Client organization OS. Client organization is OS is what? Linux. But Docker code is designed to execute on Windows. But in the Docker container, Windows OS will be there. So there will be two OS, right? One is host OS. On the top of it, Docker engine or whatever Docker software is there. Their Docker container. Inside that container, code plus environment. In that environment, again, some OS, some database, some Java will be. In host computer also Java may be there or database may be there. That is different. They are different. And in the container, what OS is there, what database is there, that is important because our code uses that setup, right? Everyone convinced or not there, guys? Host OS will change based on the setup or what profile. Yeah, Docker containerization, guys. What is there? Docker containerization. Yeah, Docker containerization. Give me 1 minute, guys. Yeah. See, guys, this side what? Operating system, virtual machine, servers. Virtual machine means it's like a logically created machine in AWS. AWS is a internet based. There also we can create computers, but they are not real physical computer. They are logical computers. That's why they are called virtual machines, right? Okay. Yeah, library. These are jars, all dependencies. This is my software setup now, my dear. Front end, back end development. So these thing, both thing we pack. Why the symbol is like this? Yeah, we are in the container, both code and environment is there and they are shipping. So there's a ship with containers. So that code becoming more shippable or not there. More portable or not there, guys. Okay. Docker logo is carrying what? Is ship carrying components, indicating Docker code. Docker makes the code easy. Code and environment as easily shippable code and what environment. Docker container which hold code plus environment are easily shippable or portable across the multiple machines. When we move Docker container to any machine, that machine just need to have Docker software or engine so that Docker managed code can be executed in the software setup of Docker container itself. No need of installing software separately in a boss. Okay, next one. Once we keep project code plus environment setup in Docker container, we can make that Docker container Docker container working in any machine having any OS for any developer or what end user. For any developer or what end user. Are you getting my point there, guys? Any machine having any OS for any developer or what end user. Docker passes the statement to programmers or developers. You just keep application code ready because Docker itself arranges all the software, OS, and etc. that are required to execute the code in different profiles or what environment. That are required to execute the code in different profiles or what environment. Everyone getting my point there, guys? Super. Docker definition. Yeah, tell me. Docker is a tool or platform for packing, deploying, and running the application with what? Portability. Running the application with what? Portability. Docker is a tool or platform for packing, deploying, and running the application with what? Portability. Are you getting my point there, guys? Super. Okay. Advantages are what? Docker. Docker enables the developer and DevOps team to separate our application or project and infrastructure setup so that we can deliver software project quickly. We are packing code and environment. If someone is ready with a hardware setup, we can happily give the code and we can execute or not there. Docker packages the software project and its environment into units called Docker container that have everything that the project needs to run, including libraries, tools, code, and runtime setup. Yes, na Docker containers are having every setup that is required to run the code or not there. By using Docker style packing, deployment, execution, and shipping, which is quick process and which reduce the time delay between developing the code in dev and running the code in what? Prod profile. So it will save the time or not there, guys. We develop and pack code and environment. Same thing we give for a tester. They will test it. They just need to arrange the machine. Every code and environment is already there. We give the same code to UAT. They also test. They just need to arrange the machine, hardware setup. Nothing has to be arranged related to software, because whatever we releasing as a Docker container, that comes with what code and environment together are not there. A typical Docker container looks like this now, guys. Project code, environment like OS, DB, JVM, server libraries, and etc. Entire environment is coming or not there. Docker architecture high level. Okay. To the Docker software, we give instruction using Docker file. Then we use build command that gives me Docker image. Docker image like a class kind of thing, planning kind of thing. When you run the Docker image, you will get Docker container. And this Docker container actually represent code plus environment. This Docker container actually represent code plus environment. We release Docker containers to different machines to execute the code of Docker container in the environment are set up that is there in the Docker itself. All after all, Docker container maintains both code and environment are not there. We release Docker container, only machine should be arranged. Softwares you need not arrange. Only in that machine, Docker software should be there. Basic OS and Docker software is there means Docker container can run. And this OS can be anything. Why? What about your code and OS and within the container only that OS is there. Okay, guys. Tell me main components of Docker architecture. Using Docker file, we give instruction to Docker to create a Docker planning, nothing but image. When you run the image, you will get a Docker container. But once image is ready, guys, we try to keep in what Docker registry, like dockerhub.com, so that others can take in and use it. So that others can take it and what use it. So Docker file contains configuration that are required to build Docker image. Docker image is kept in what Docker registry. Okay, so that everyone can access that image. When you run the Docker image, you will get what Docker container, in which actual what code plus environment is packed. Set of instruction to build Docker image is there in Docker file. Docker image package which contains the planning of what source code plus environment. Docker registry. The registry where Docker images are what? Available. Docker Hub, AWS, ECR, etc. Docker container. An instance of Docker image using which we can run the application code in certain environment or profile that is specified in what Docker image. Docker client. An implicit component in Docker tool or software who is actually responsible to execute the Docker commands. When Docker software is installed, Docker client comes automatically where we can run the Docker commands. Keeping Docker desktop software ready in Windows OS. Okay. And I said, no, every machine should have a Docker software. Right now we are having Windows OS. So in Windows OS also, you should have a Docker software or not there. In Windows OS also, I should keep Docker software ready or not there, guys. Super, guys. Tell me. Yeah, before installing, guys, before installing W2, if you go there, there is given instruction how to install. In that one, two softwares you have to keep ready. WSL2, one thing you have to keep, Hyper-V you have to keep ready, boss. Hyper-V and WSL2. Okay, here how to arrange WSL, how to arrange Hyper-V, that procedure is given. Make sure that WSL2 and Hyper-V installed in your computer and they are started. Okay, in Windows search box, search for Windows features off, on and off. Select Hyper-V, Windows subsystem for what? Linux. WSL2 means Windows subsystem for Linux. That means in Windows, we can bring the effect of Linux commands. And installation process, restart the computer. Okay, fine. Okay, tell me Windows feature. Windows feature on and off. What is there, guys? Windows feature on and off. Yeah, search for Hyper-V. Already there? Search for Windows subsystem for Linux. Yes, both are selected. If they are not coming, what to do I have given here. If they are not coming, what to do I have given here. How to install WSL2, how to install this procedure is given, right? Okay. Confirm WSL2 installation. Okay. So how to confirm WSL2 installation? Go to any command prompt, guys. WSL. Okay. WSL. Any folder, guys. WSL hyphen status. WSL. Not installed, installed. No, anywhere I can do that. That's not a big issue. Command prompt, guys. Yeah, it's coming or not there. WSL hyphen version. Okay, it's also coming now, my dear. Okay. Download Docker desktop for Windows. There's one more software called Docker desktop, guys. Okay. Docker desktop. It's a setup file you have to download. It's a setup file, Windows, all this stuff. Already it is there in my system, guys. Okay. Create an account in docker.com before launching Docker desktop tool. Okay, docker.com, I should have a account, guys, which is acting as a Docker registry. All image, whatever new images I create, I will go docker.com. Okay. Sign in. Sign in. Okay. Natras Docker is the tool. Say continue. Password has come. Okay, fine. I don't. So this is my what, my dear? This is my what? This is my Docker. Docker registry, guys. This is my Docker registry. Okay, fine. How to launch Docker desktop tool? Wait a minute. So now here already I installed Docker first Hyper-V, next WSL2, then Docker desktop you install. But before launching Docker desktop, before launching what? Docker desktop, definitely we have to go for it. Docker desktop. Where is Docker desktop is not coming? Money, don't join, guys. Don't join, please. Okay, don't join. These people will misuse your data, please. Yeah, these people will misuse your data. Don't join this kind of groups. Money, already Naresh, I do so many groups are there, right? Placement assistant cell is there. What is your personal group? You want to misuse the data? Guys, don't join. This is unofficial. Money, last warning. If you do this again, it will be, you will be. Okay, fine. Let it be. Okay, guys. Tell me. We are ready with what, my dear? Docker desktop. Okay. Docker desktop. That is going to be Docker. that Docker engine in my system. Yeah, why Docker desktop? Yeah, this is my Docker desktop, guys. Why it is not responding? Open, it won't come up. What happened to this? Run as administrator, say okay. It is not responding. Actually, it has come, but I stopped it. After that, it is not responding. Okay. Services.ms. Let me check. What's the problem? Docker desktop service. Yeah, I have stopped it. I have to start it. Once I start it, it will come. What's happening, guys? Fine, no problem. Without that also, one command prompt also, we can do the work. Okay. If that is there, it becomes quite GUI one, it becomes easy. Hmm. Because of GUI one, it becomes easy. Docker desktop, Docker desktop, it's in running mode, but why GUI is missing? Manual only, apply, okay. Hmm. Do I need to restart the computer? Okay. If needed, we'll restart the computer. That's not a big issue. Okay. So we are ready with what? Docker, this. See, what is there? You create account in docker.com. That's good. Later, you go for sign in there. This Docker desktop and docker.com both will be in sync. Docker.com has Docker registry, guys. Fine. Okay. Now, listen carefully. Now, I have to check a Docker version. That's fine. Docker info. Okay. We are getting various details about Docker are not there, guys. Okay. That's good. Next. Various information about Docker. Yeah, we can search for existing Docker containers, guys, existing Docker images. How to search for it? There is a command called Docker search JDK. Not only my images, already a lot of images might be there, na? Those images. Docker search. Open JDK. Docker search open JDK. Tell me. What is there? Docker search. What's there, guys? Docker search. Okay, Tomcat 11. So it's giving all Tomcat related images are not there. That means already in docker.com, some images are there. If you want, you can search in docker.com also, guys. Yeah, launch Docker desktop. Fine. Now it is launch. Yeah. See, already some Docker containers are there. I'm deleting all the containers, guys, because I want to have everything fresh here. Container selected, anonymous volumes are associated. Yeah. Docker images, two images are there. I am deleting it. These are user defined images which I created for last batch. Here are my card containers. Here are my what? Images. Docker Hub. It will connect to Docker Hub. Okay, go to images. Search images to run. Okay. What is there? Tomcat. So Tomcat related so many images came now, boss. Okay, JDK. JDK related so many images are coming now, my dear. JDK related many images are coming there or not there, guys. Super. Sir, after installation, once restart the PC, sir. Did anyone took recordings? Once restart PC, not required, madam. In the website, you have to say launch Docker desktop. Okay. Fine. Okay. So this is how we are ready with what? Setup. This is how we are ready with what? Setup. Here are my what? Containers. Here are my what? Images. We can search for ready-made Docker images either from command prompt or what? Show above. Or we can use same search in the GUI screen Docker desktop. Open Docker desktop images section, search images to run, search for images like what? Open JDK, MySQL, Oracle like this. We can search for. For ready-made software, Docker images are already there. Using them plus our code, together we create one more image. And those images we can keep in what? Docker registry for global visibility. Got it? Okay. I think you got it. At the end, what is a single point agenda, boss? What is that? Code plus environment packing. What's the advantage? To make our code more and more portable. No other thing. To make our code more and more portable, we have to take the support of this one or not there, guys. That's great. File, open. Next, what is there? File, open. Class content. Tools FS. Where is this? 905. What is this? Docker. Okay, session 2. Yeah, in session 2, we'll try to know more internals about Docker. Yeah. Working with the sample Docker Hello World. Hello World is one sample Docker image, guys. Hello World is what? One sample Docker image. Okay, I'll go to one folder, guys, instead of all this stuff. So now Windows command prompt is like working as a Linux command prompt. All Linux commands we can type there because we installed WSL and Hyper-V. Both are required. Go to this folder. Go to D drive. Docker applications. Okay, that's good. Docker application. I'll create one more folder, guys, for our batch folder. FS tools. What is there? 905 FS tools 905. Okay, what kind of structure I followed for other batches? Let me check. 701. Okay, some demo folder. Okay, fine. We'll follow the same rhythm. Yeah, here is my new folder demo one. New folder demo one. New folder demo one. Tell me. What is there, guys? New folder demo one. Working with the sample Docker image. What is there? Hello world. Okay. Activate Docker desktop. Use the desktop icon that's already there. We already activated. Pull the Docker image. Docker pull hello world. What is there? Docker pull hello world. Hello world. Docker pull hello world. Here is my word. Docker pull hello world. Pulling from library hello world. Pull complete. Here what? Digest. Download newer image for hello world latest. Okay, we are ready with the Docker image or not there? We are definitely ready with what? Docker image. Yeah. Pulling from library hello world. Tell me pull complete. Digest. Status. Docker.io library hello world latest. We are getting this one or not there, guys? We are definitely getting this one or not there, guys? Okay, that's good. Docker pull hello world. One image came. Okay, how to see the list of images, guys? Docker images. Okay, Docker images. It will give all the images. Hello World is one ready-made image that is there in Docker Hub, Docker registry. We pulled it. It came to my computer. Now it is displaying it. Okay, when you run the Docker image, how to create our own image, we'll discuss later. Okay, Docker run. Run is the command, guys. Docker run. What is there? Hello World. Docker run hello world. Okay, fine. What is there? To generate this message, Docker took the following steps. The Docker, this output coming means, okay, image is executed and container is created, output came. This message itself, Docker container execution. They wantedly designed like that. Hello. This message shows that your installation appears to be working correctly. To generate this message, what it has done internally. Okay, this Docker software is having one Docker client. Docker client connected to Docker daemon, one daemon thread. The daemon thread pull the hello world image from the Docker hub registry. The Docker daemon created new container from the image which runs the executable that produce output that you are currently reading. The Docker daemon streamed that output to Docker client and which sent to what? Your terminal. Terminal means this command. And this itself, this output itself, output of hello world execution. See, in Docker hub, image is there. Docker pull image name. If you run the image, you will get container. Docker run image name. This output is coming. In the output, they have given internals. Okay, guys. Now the question is, you want to see all the containers that are in reactive mode, guys. Docker PS. Docker PS -A. Actually, only PS also fine. Docker PS. Okay. Now listen, hello world is coming or not there? Yeah, PS -A. Here only PS I kept. To list active Docker container, to list out all the Docker container. Active, inactive, say running, because already execution completed. It is just active container. This is to get what? Active and inactive both. Both are there. When it is running, if you issue this command, then you will get that. Oh. Okay, you want to stop any container, guys? Okay, if you want to stop any container, every container is having container ID, now my dear. Okay, copy this. Docker stop. Tell me paste. Container is stopped. Okay, now Docker PS -A. Still coming. Docker PS. Okay. Hyphen means all command. Active right now nothing is there, right? Right now no active commands are there. No. If you want to remove Docker container, okay, Docker RM, okay, Docker RM paste. Remove the container. Containers are not there. How to check container is there or not there? Docker ps-a, not there. Next one, guys. Docker, okay, no, images, Docker image. Still image is there. Container is deleted, but image is there. You want to delete the images? Yeah, we have something called, everything is command, guys. Everything is command. Docker RMI image name. What is there? RMI. Docker RMI image name. What is the image name? Hello. Deleted. Image is deleted or not there? Definitely image is deleted or not there, guys. Okay, no doubt. Docker images. Hello world latest this 4 months ago, 20.3 KB, right? Yes. So here is the story that we have to focus, my dear. Come on. Understanding my statement, guys. Okay. Okay. Now you observe Docker images. Mr. Focus man. So drowsy today. I should pack you, not the code and environment. Okay. Go out and wash your face and come back. So now images are gone, containers are gone, everything is empty now, my dear. So like this, some commands are there or not there. Okay, now listen. I can do the same thing over here. Go to images section, search images to run. Here I will search for what? Hello world. Hello world. This is hello world is there now, guys. Pull it. It's pulled, right? Yeah. You run the image. When you run the image, we are getting this output or not? See, commands are there, same thing here also there. Sir, why are you teaching command? This is looking easy. It looks easy, but in sometimes industry uses both. Yeah, now we are getting output means it's running or not there, guys. Okay, now go to list of containers. One container is created now, boss. You want run again? It's not giving up. Maybe I have to run in the images section. You want run? Yes. One more time output came. Go to the container section. 2 times I run, 2 containers are. You want to delete any container? Yes. Select this and delete. There's no need of you remembering commands, my dear. There's no need of you remembering commands. Images. One image is there. You want to delete it, you can delete it. Same thing, now whatever I discussed through commands, same thing I have done through what? GUI. Okay. So now let's see the internals of this entire discussion. Docker image comes from Docker Hub to work folder as only copy, but we create multiple Docker containers from one what? Docker image. Yeah, this is called we given command in the terminal or not? Dollar symbol means Linux or Windows terminal, right? Hello world, Docker run hello world. After getting the image I am talking, that command gone to Docker client. Docker client is giving that command to daemon thread, which all continuously listens for commands. Okay, this This will search for image locally, whether that image locally available or not. If not available, it will connect to Docker registry, downloads the image. That is D. That is what D. E1. Docker container is created because directly image downloaded, I am directly giving command to run the image, right? Emoji is pulled. That by running the image, container is created. Docker container executed. Come on. Because we are asking to create a container and run. Whatever output comes to, that output comes to what? Docker client from demo thread. Demo thread will give that output to terminal or not there. Docker client is a component in a Docker tool that receives the command from Docker terminal and executes the command. Docker daemon thread is another built-in component in Docker tool, which actually performs what? All the activities. Which actually performs what? All the activities. Convinced, my dear? Come on, guys. Docker run command can internally perform Docker pull command to get images from Docker Hub if at all that image is locally not available. If at all, if that image is what? Not locally available. Listen, one thing is very interesting, guys. So right now, I deleted everything. Docker images. No images. Docker ps-a. No containers, right? So generally we pull the image, then we run the image to get the container, right? Okay, now tell me what is there. Docker, no pull. Directly you can mention the image. What happens, if there locally, it will use local copy of image. If not there, it will see, it is not there locally, not there. So it's happily bringing from what? Docker Hub, and then creating what? Docker container and running the Docker container. See, still we are getting output or not there. So that's why we can directly run the image, though it is not there locally, then it will collect from Docker Hub and do that. But in GUI, we cannot do that. In GUI, we cannot do that. Why we cannot do that in GUI? Because in image section, there is no question of running the image without getting the image, right? Okay, first you have to search the image, then we have to go for it. Yeah. See, guys, without deleting container, if we try to delete the image, we are getting error or not there. Okay, now you delete the first container. Without deleting object, can we delete the class? It's meaningless, right? Yeah, tell me, guys. Commands we can do here also. We can do. Same diagram I kept in another angle. Same diagram we kept in another angle. Client is giving commands. They are going to Docker host where Docker software is running. And that is linked with what? Docker registry. That is linked with what? Docker registry. Everyone getting my point, guys? Yes. Okay. Sir. Okay. Now, once again, right now, Docker image is not there. Docker ps-a not there. Right. Docker run hello world. Docker run hello world. Docker run hello world. Tell me. Docker Docker, there's a command, guys, to delete all images and all images and all containers in single command. Docker system run-a. All stopped containers, all networks that are not used at least by one container, all images at least one container associated to them, and all build caches. So everything it will delete are not there. Deleted. Whatever locally available, they are deleted. Tell me, Docker ps-a empty Docker images. I don't want to delete each container, each image separately. I want to delete all containers, all images in single stretch using single command. System -prune a. It's very danger command. You don't want to go by one. You want to delete all images. Suppose, for example, I said Docker pull OpenJDK. I got some OpenJDK something. Error response, fine. Okay. OpenJDK is not directly there. 1 minute. Docker search OpenJDK. Yeah, OpenJDK. There are so many OpenJDKs now, guys. C image OpenJDK, right? Docker pull CIMG OpenJDK. Docker latest not found. Then why it is giving there? Why it is giving there? 1 minute. Fine. Here not happening now. Fine. But we have a solution for every problem. Go there. Docker desktop. No, I think this is the window. No? Okay. This is the window. Images. Search and run. Here I will search for what? OpenJDK. OpenJDK. Circle CI. Images. I think it's still pulling, boss. It's still pulling, it seems. I just want to prove not only our image, any image will be deleted. Okay, it is taking its own time, but that is a danger command. Be careful, because once I run it, all locally available images and what containers will be deleted if they are not in active state. If they are not in what active state, that's why be careful about it. Okay, it's taking time, guys. Fine, no problem. Yeah, now what do you want to do? Yeah, it's a danger command. We just checked that command, guys. Yeah, now I want to make, now I'm interested to make one small Java application, standalone core Java application. Okay, as a Docker image container. That means JDK software in Java .java .class file I want to pack. This is my requirement. So this packing plan we write in what? Docker file. That's a fixed file, guys. Docker file, no extension, nothing. Okay. When you use build command, what happens? When you use what? Build command, what happens? When you use build command, you will get Docker image. In that image, OpenJDK image is there and your code is there. So when you run it, what happened? The command should execute or not there. Super. Okay. When you run, container is created. What is there in Docker folder, guys? From OpenJDK. When I mention like this, okay, it is trying to use OpenJDK image while creating your image. Work folder, some logical folder name, guys. Copy dot slash to everything. Everything of current directory you copy to what? That. Next one, run java c sample.java. We are asking to run it. This is for compilation, right? CMD, Java sample. From to get the JDK, this one, work directory to specify some logical folder as work folder. Run command execute during Docker image creation. Okay. CMD command execute during what? Docker container creation. That's the one difference. One more difference is there. If you place multiple run commands, all of them will execute. If you place multiple CMD command, only last one will execute. Only last one execute. How many commands you place? Only last one execute. Right now we are placing one time for different sake. I am telling guys. Run runs, CMD also runs. But when you keep multiple CMD commands, only last one will run. When you keep multiple run, they will run. Run will execute during image creation. CMD will execute during what? Container creation. Okay, guys. Now what I do is I go to this place. Okay. Yeah, demo one. Demo one. I think right now everything is empty now here. Okay. Docker system prune -a. Delete everything. Come out. Okay. In demo one, first I will put new. What is there? File. Sample.java. What dot Java, guys? Sample dot. Open with Notepad. Open with what? Notepad. Here is what? Sample dot. Public class sample. What is there? Public static void main. String args. Into a is equal to 10. B is equal to 20. System dot out dot println. Sum is a plus b. End of the main method, end of the class. On benefit of doubt, you test once locally. I don't want to take chance. No, without Docker, you test once because it's better to test once now, guys. Sample.java. Java sam. Yeah, sum is 30. Fine. Locally it's running. Okay, now once it is running, there's no need of having this dot class and dot Java. Only dot Java is enough because everything will be taken care by dot class. I need not to have remove it because everything should happen during container creation, image creation. So here I need to develop one file. What is the file? Docker file. Look at this fixed file, guys. The fixed file. If you want to change it, there is a command to give. But right now I don't want to change. Docker file is the industry standard. If you follow this one only, everyone recognize that's a Docker file, right? Okay. Now I'll take another file, guys. New file, save as Docker file. File save as Docker file. From what is there? OpenJDK. From OpenJDK. That is quite case sensitive. Be careful. From OpenJDK. That's fine. I don't want to take chance, guys. Here also lowercase. Workdir slash app1. Workdir slash app1. Copy. Copy. Tell me. Dot slash app1. Everything of current direct. That all commands will run from app1. That's why I'm copying everything from what? app1 folder. Okay, next, what is the next command we got? Yeah, run javac sample.java. Run, what is this? Javac sample.java. Next, cmd java. What is there? cmd java sample. cmd java sample. That's good. Great. Fine. Docker file is ready. Okay, code is ready. Now, in that code, some JDKs I asked to download. So combining all these things, I want to create my own image now, guys. Okay, for that one, we have to use Docker build command. What command? Docker build command. Okay, Docker build, you have to specify the image name. Yeah, Docker build -t image name dot. Everything of current directory you have to keep in what? Image. Okay, now guys, tell me. Docker build -t. Okay, image name. Okay. Yeah, tell me guys, 905 Java application one image dot. Fail to solve Docker file. Open Docker file, no such directory or what? This. Oh, I have not saved in Docker. Acha. Docker file is not saved in right folder, boss. File save as. Oh, it saved somewhere else. Yeah, E dry, good observation. Tell me. E dry class content? No. No, not D dry. D dry. Okay, D dry, Docker apps. Docker apps 905 demo 1 Docker file. I don't want to see getting default extension, guys. Double quotes, Docker. Everyone getting my point there, guys. That's good. From OpenJDK, work directory, copy, Java C, all this stuff. Yeah, come to this command prompt, guys. Image 1, 905 application 1. Yeah, tell me. Error failed OpenJDK to resolve source metadata. It is saying that OpenJDK is not there because this image is not there, nothing else. Okay. We are thinking 1 minute. Docker search OpenJDK. Yeah, this is time to time will change, guys, sometimes. OpenJDK pre-release non-production build OpenJDK right now is there, and stars also, so many are there. That is circles here, but only OpenJDK is also there, guys. Okay, fine. 1 minute. Okay, no problem. We'll see. No, sir. File name is sample only, na, sir. What is the file name? That is a logical folder. Anything I can give. That's a logical folder. Anything I can. It's no way. It's a logical folder. Anything I can give. X, Y, Z. Anything you can give. 1 minute. 701 demo 1 Docker file open with notepad from OpenJDK. Yeah, that's good. So that means that should be there, but it is not recognizing OpenJDK. Why so? 1 minute, 1 minute. OpenJDK. Actually, sometimes these image locations will change. We have to bear the headache. Sometimes these image locations will change and we have to bear the headache. Wait a minute. 905 demo 1. Okay, is this Docker file. Open with what? This notepad. This one. Yeah. Workdir from OpenJDK. That's good. File. What is there? Save. In the search OpenJDK coming, but internal load metadata docker.io library OpenJDK latest. It is saying that OpenJDK is not there. Fine. What to do? So we have to try what? Another image. Okay. Now 1 minute. I'll try to go for Docker pull OpenJDK. I think we tried it earlier. It has not come now. Yeah, it's not coming. It's not found. That means they removed it or it's moved out. We cannot do anything. When it is moved out, right? Okay, now we have to use some more thing where this OpenJDK is working. Where is that? Circle CI, that is also giving problem now, guys. Docker images based on what? Adoption OpenJDK. Okay, CMG, 1 minute. CIMG OpenJDK. What is there? CIMG, circle, yeah, CIMG slash, this slash only now, guys. Save it. Save this. Yeah, if luck is not good, this is the only headache, guys. These ready-made images don't stay in fixed location with fixed name. Sometimes they change. Error internal. Load metadata for Docker IO CIMG latest. Then what is the one, Rababu? No, that's fine. That's fine. Image not found, but there should be found image, one or other image, na boss. Okay. Because up to last batch, they have given support for what? OpenJDK, but now they are not giving. Okay. Because if I go for ChatGPT also, they suggest OpenJDK only, which is not running. We know that one, right? Okay. Fine, we'll try. You start the work, we have to complete now, boss. Yeah, these are the challenges. When consistency is not there from registries, these are the challenges. Yeah, tell me. From OpenJDK, alternate in Docker image creation. Yeah, for this only this much headache. Okay, for this only this much headache means, for this only this much headache means, come on. Okay, for Tomcat server, how much headaches it should be going to be? Yeah, yeah. Tell me from Eclipse. Okay, fine. From Eclipse 17 JDK, something is there now, guys. Let's try. Okay, this is the only one headache that you have to bear. Until it works, you have to try. Until it works, you have to try. Uh, I'll remove above what is there in the file. What is there? Say. Yeah, tell me, boss, where is this? Docker build -t this. Positive sign. Yeah, please. Yeah, it's building image. It's really building image. We are good news, but you have to be patient like this, right? Hmm. Compilation, everything is done. Now image is ready, right? Now we have to run the image or not there. Docker run 905. What is this? Java, Java -app, yeah? app1 image. What's the name, Rababu? Image. Right here is there, na? IMG. Okay. This is the image, na? Java app1. We are asking to run the sum is 30. It's running or not there? It's now running or not there, guys? Okay. So like this, we can make code in this. Now let me put this code in what? Repository. 1 minute before that, let me take this. Yeah, otherwise, you see, till last batch it's running. Okay. Yeah. Now what should I say? If OpenJDK is not running, OpenJDK image. If OpenJDK image, if OpenJDK image is not working, then prefer using what? Then prefer using what? Prefer using this. Image. OpenJDK is not working, then prefer using what? Eclipse 17 JDK. Fine. But how everyone can enjoy if I kept in repository now, boss. Everyone can enjoy if I kept this one in what? Repository. Right? Okay. Let me keep this image in repository. Okay. Create repository in Docker Hub. Okay, we already created. Fine. Okay. Now Docker login -u natras docker -p docker @1234. So I have to connect to that one or not there. Okay. Yeah. Tell me. Otherwise, I think already time up. So fine. So whatever it is, we'll discuss this part later, guys. We'll just we'll worry about only content creation, keeping in the internet, again bringing all these things we'll do later. Okay, once again check it out. I delete everything. I do everything freshly from the scratch. Okay, na? Yeah, first I prepare Docker file. Then I developed sample.java. Sample.java I tested locally to make sure that code-wise no problem from our side. Okay. Docker file. So we tried from OpenJDK, it's not working. Then we have to ask ChatGPT, which is working, give me that it's there. So be mentally ready for that. Okay. Today I have given, tomorrow if it is not working, you have to search for other alternate. Yes, na? Because that's not my image. That's a image came from what? Docker registry. Okay. Now what is there? Docker system. Rune hyphen A. Say yes. Brune hyphen A. That's good, guys. Tell me. Tell me, guys. Tell me. Darker. Darker build is the command. Hyphen T means continue the same file. So look for I build a Docker file only. Don't ask for new file. Okay, na? Uh, nine. Okay, 905. Not compulsory. Anything you can give. Java application image one dot. Take everything from current direct. Image creation is happening. Yeah. Yeah. Tell me next one. Java Docker. What is there? Yeah, Docker images. My own image is created or not there? Okay, fine. What is next one? Docker run. Docker run. What is there? Java 905. 905. Tell me. Java hyphen app hyphen image one. Not only it creates container, it executes the container, guys. Some 30. Output came or not there? Yeah, this is how we have to create simple one. And we try to create web application one tomorrow. Then we will try to develop Spring Boot one, how to create Spring Boot based Docker, whatever it is, right? So all these things we will discuss, guys. That's not a big thing. Okay. Click on this, guys. Click on this. Okay, let's upload the image. I think you enjoyed the basic concept.